In this video, we are going to discuss one very interesting application of the formula for the Laplace transform of the derivative of a function, which is somewhat unexpected and also unintentional. Okay, so for that, first let us recall the formula for the Laplace transform of a derivative of a function. If we have a function f and we take its derivative and then we take its Laplace transform, according to the formula, this is equal to s multiplied by the Laplace transform of f minus f evaluated at 0. What we're going to do now, we're going to try to apply this formula in the case when f is the function x times e to the power x. Before we do that, let's recall that the s here, the variable s, is the variable on which the Laplace transform depends. So the L of f over here is going to be a function of s. So a more precise way of writing down the right-hand side here would be to say s times L of f of s minus f of 0. There is no hidden variable there because here what we see is simply the function f evaluated at 0. In a similar way, there is a hidden variable here. Laplace transform of f prime also depends on s. And so the left-hand side should actually be Laplace transform of f prime evaluated at s, and that is being equated to the right-hand side in the formula. I see now that what I wrote wasn't very visible, so let me make it more visible. There we go. Okay, so once we get that clarification out of the way, let's come back to considering f of x being equal to x times e to the x. Let's see what happens when we substitute this into this equality. Well, to do that, first we have to know what is the derivative of f. When f is equal to x times e to the x, the derivative of f will be x times, maybe I should rather say e to the x plus x times e to the x. This is by the chain rule, of course. Now we are ready to put everything into the formula. We then get that Laplace transform of e to the x plus x times e to the x is equal to s times Laplace transform of x times e to the x minus f of 0. We forgot to calculate that. Let's calculate that as well. When f of x is equal to x times e to the x, f of 0 will be equal to 0 put in the expression in the place of x. So it will be 0 times e to the power 0, which is 0. So we have there minus 0. Now, what we're going to do is to make use of linearity of the Laplace transform. So then we'll have L of e to the x plus L of x e to the x equals s times L of x e to the x. We now recognize that the left-hand side has this term here, which is the same term that occurs on the right-hand side. So what we want to do is to bring those terms on the same side and group them together. Perhaps we can bring over the left-hand side to the right-hand side, but also swap around the equality and eventually get s minus 1 times L of x e to the x is equal to L of e to the x. But for e to the x, we have a formula that tells us what the Laplace transform of e to the x is. According to the formula that we know, Laplace transform of e to the power a times x is equal to 1 over s minus a. We want to make use of this formula in the case when a is equal to 1. Then we'll have that Laplace transform of e to the x, with a being equal to 1, is equal to 1 over s minus 1. Now, we can write down L of x times e to the x equals 1 over s minus 1 squared. Now, the wonderful thing with this is that we have just derived a formula for the Laplace transform of x times e to the x, knowing what Laplace transform of e to the x is. And this is the application that I had in mind, using the formula for the derivative. To be more precise, the formula for the Laplace transform of the derivative, and using the formula for Laplace transform of e to the x, we can now get the formula for Laplace transform of x times e to the x. Now, isn't that wonderful?